Okay, so you're about to take the chromatography quiz, and the page is going to look like this. And what these represent, this area from down here all the way to the top up here represents the chromatogram. That is that little slip of paper. I've just lined them up side by side. You can see that this line represents the solvent front, and then we have some different color spots. What you're going to be doing is calculating the RF value for these, and so I'm going to go through that process. First thing you need to do for each of the different kind of pens is to measure from the origin all the way up to the solvent front. How you measure, you can see that these lines are sort of they're curved, but one of the things you can do is if you always measure at the topmost part, because you're using that as the denominator for all of your calculations, it's not going to matter. So just be consistent. Same for these. When you're measuring the distance of these spots, either always do the lowest end or the farthest end of any of those individual spots. So for example, I could measure up to here for pink, or I could measure up to here for pink. What I'm going to do is I'm going to measure to the very top, the leading edge that all of these colors traveled. So you're going to need a ruler and a calculator for this activity. I am not going to, I'll do sort of one with you here so you can see what's going on. So I've got a measurement here. This is 8 centimeters, and so I'm just going to mark right on my paper that the solvent front is 8 centimeters so that I don't have to forget it. Okay. The next thing I'm going to do is for this first spot, I'm going to measure, again, that leading edge. So I'm measuring up to the very top edge of how far that one got. Let me move this over here so you can see what I'm doing. And so we have 2.6 centimeters. So again, I'm just going to mark these right here. It doesn't matter if you use centimeters or inches, just be consistent. I like to use the centimeters because everything is done in tens instead of in sixteenths. So again, we're just going to measure each one of these out. 2, 3, 4. This one's about 4.3. 4.7. And this last one is 4.9. From that point, what you're going to do is you're going to start figuring out your RF values. So on the bottom, you're going to see what looked like the other side of your chart when we did this in lab. So you're going to list those colors. My first color is sort of a light blue color. I'll mark that in. And the RF value is the distance the color traveled. So I'm just going to mark it down here for this one so you can see, divided by the total distance the solvent front traveled, which in this case was 8 centimeters. So all of these in this row are going to get divided by 8 centimeters because they're going to be the same. So take the calculator out, 2.6 divided by 8. Try this again. Is 0.325. Remember to keep all of your decimals out. So we've got 0.325 for that first one. And so I would continue on with the entire process. So the next one I'm going to do is I'm going to look at this sort of brownish one. I'll mark the color down, brown. That one is 4.3 centimeters away. So I'll divide 4.3 by the 8 centimeters to get my RF value. And when I do that, I get 0.5375. So you're going to continue that process for all of the colors. Remember that not all the boxes may necessarily be used. For example, this sample right here only has one color spot. So you're only going to use the first box. You're not going to use any of the rest below it. So it looks like a lot, but you're not going to be filling out every single one of them. What you're going to do then is, just like we did in lab, these are all known pens. You're going to try and match one of those knowns with the unknown pen. So you should look for the same kinds of distributions. You can look right across right now. I have set this up so that you're not going to see the exact same pattern here, but what you want to do is you want to look for the same pattern of colors. So blue will have to be first. So right now I can tell you without a doubt that the barrel pen is not my unknown because it doesn't have a blue first one. Okay, now when I'm looking at, for example, the School Smart Roller, they both have a first blue mark. It doesn't matter how much they traveled because you're going to be comparing it to those RF values. Because the solvent front traveled farther, I would expect these spots to move farther as well. So just do all of those divisions. So you're looking for the color patterns to match in order. So I would look for blue, green, that sort of orangish color, and then a brown. In any one of those, I can rule out any one of them that do not have that color pattern. And then from there, if I'm left with 2 or 3 that are potential sources, I'm then going to go down here and try and match my RF values. Okay, because these are a quotient and they're a unitless value, if I think that this is the match to this one, even though this traveled farther, we would see an RF value that corresponded to this one if that was to be the match. When you are assessing that, that's what I'm asking for on the back. So using the data, the calculations, write the analysis of the unknown chromatogram. So which one is the unknown? What is its identity, and how do you know? Make sure you're being specific and use details in your analysis, just like we always ask for. 1 paragraph minimum, 8 to 10 sentences. Good luck.